Energy cannot be annihilated, not by flames, not by the passage of eons, not by any force the cosmos has wielded across 14 billion years. This assertion is not a matter of faith, but the first law of thermodynamics, a principle that has never once been violated in any laboratory, inside any star, or during the collapse of any galaxy. And yet, you as a conscious being are going to perish. Every atom that composes your frame will still exist a billion years from now, and the vitality driving your pulse, igniting the very reflection you are having at this second, which organizes itself into the singular, unrepeatable blueprint of you, cannot be eliminated. Physics strictly forbids it. The question this evening's presentation will nestle into and refuse to release you from until you have sensed its full gravity is this. If nothing about you can be annihilated, what does it genuinely signify that you will vanish? By the conclusion of this presentation, you will grasp the tangible physics of what befalls a human at the instant of departure, not the biology or the verse, but the physics, and you will discover that the universe holds a reply far more peculiar and exact than anything provided by doctrine or speculative fiction. You already know on a gut level that nothing truly ceases to be. Observe a frozen cube dissolve. It does not disappear but becomes liquid, and if left in a heated space, that liquid turns to vapor, invisible and scattered into the room's air, then the structure, then technically the entire globe's atmosphere, and at no point did the water stop existing. It merely stopped being arranged a way you could point at and label an ice block. Place a timber into a hearth, and the identical rule governs. As a log does not vaporize into nothingness, its mass changes into heat, light, carbon gases, mineral residue, and trace vapors that float into the world to eventually compose new trees, fresh earth, and novel life forms. Chemists have understood this for over 2 centuries, since Antoine Lavoisier demonstrated in 1789, and the finding has never been reversed, establishing that mass is neither created nor destroyed, but only transformed. You have navigated your entire existence encircled by evidence of this decree in every flame you have watched extinguish and every cube you have watched dissipate. Yet you have simply never directed it toward the one transition that frightens you the most. A second statute lurks behind the first, and it is the one that truly counts here. In the 1850s, the scientist Ludwig Boltzmann sought to clarify something that feels obvious, but had never received mathematical proof, specifically why a frozen cube dissolves into a pool, while a pool never spontaneously refreezes into a cube on its own. Both pathways conserve energy impeccably, and nothing in the initial law forbids a puddle from reassembling itself into ice. Yet you have never observed such an event and never will. So Boltzmann's resolution became the second law of thermodynamics. There exist vastly more arrangements for water molecules to exist as a disordered liquid than as a structured solid. So statistically, chaos prevails, not because the cosmos favors disorder, but because there are simply more routes to be disordered than ordered, and given sufficient duration, the probabilities always collapse toward that direction. This single revelation, that there are more ways to be broken than whole, serves as the actual motor behind everything this presentation will now unveil about mortality, so apply it immediately. At the moment of your cessation, your physical form does not stop existing in any material sense. Every carbon particle, every oxygen particle, and every trace element that constructed the apparatus reading these terms a moment ago all persist, obeying the identical primary law that supervises the ice cube and the blaze. Crematorium processing converts your body's mass into heat, vapor, and a modest amount of mineral dust, mirroring the energy conservation operation of any other combustion, while burial returns you more gradually through decay via microbes and soil chemistry. Yet the final condition is identical. Dispersal, not demolition. This is where most explanations of death in physics habitually halt, with your atoms rejoining the earth and you becoming fraction of the universe once more, a statement that sounds soothing but is, in a physical sense, nearly entirely tangential, and the second you comprehend why, this presentation will feel profoundly different than you anticipated, for the atoms were never the compelling portion. The compelling segment, the one physics genuinely wrestles with, is something else entirely, buried in plain view inside a single word you have heard throughout your life without ever asking what it cost the cosmos to eliminate: information. The clarification most individuals settle for is not strictly wrong, but merely shallow, noting that your body comprises roughly 7 billion atoms, that at death biological procedures cease, and that decomposition or combustion begins, steadily redistributing those particles. Carbon into the air as gaseous compounds, water back into the hydraulic cycle, minerals into dirt, nitrogen into fresh organic material, and within a few decades, physically speaking, there exists no meaningful manner in which your atoms stay distinguishable from any other atoms of the identical element anywhere else in the biosphere. A carbon atom formerly in your left hand is chemically and physically equivalent to a carbon atom formerly in an oak, a salmon, or a legionary 2 millennia ago, as atoms carry no ownership and retain no recollection of whose body they inhabited. This fact is often delivered as a concluding statement on the physics of dying. You scatter, you reboard the grand cycle of substance, and the cosmos reprocesses you the way it reprocesses everything. A pleasant notion where debates over cremation versus inhumation on digital forums frequently conclude, treating the question as resolved. Consider how wholly repurposed you already are before you have even departed. Every breath you inhale contains on average several molecules of nitrogen and oxygen that were once breathed in and out by every historical figure you've ever heard of, not metaphorically, but as a direct result of how many gas molecules populate the atmosphere and how completely they intermix across centuries. With calculations rooted in Avogadro's number indicating that your lungs at this moment nearly certainly contain atoms that once moved through the lungs of Julius Caesar, Cleopatra, and every person who has ever lived and drawn breath on this world. Your form is not a closed, isolated object that starts at birth and ends at death, but has permanently been a provisional collection of atoms borrowed from everything that predated you, and it will simply refund that loan on schedule to everything that succeeds you. Still, this narrative possesses a colossal omission, and once you detect it, you cannot unperceive it. The atoms were never going to vanish, and no physicist has ever fretted over that. But what physics actually holds a genuine unresolved difficulty with is not the substance that constructed your body, but the arrangement, the exact irreproducible pattern of data that render those atoms into a functioning brain capable of hosting precisely the reflections, recollections, and self-identity you possess currently. Here emerges a distinction that alters everything. Mass energy is trivially preserved, and nobody can test that, but information, the accurate configuration, the pattern, the code, acts entirely differently under physical statutes, and its destiny at the instant of death remains among the strangest open inquiries in modern thermodynamics. To comprehend why, you must deliberately combust something, not your body, but a slip of paper. Take a note bearing your name inscribed in your own penmanship, and reduce it totally to ash. Every scientist concurs on the initial part, that the mass and energy of that note are flawlessly conserved, as the carbon in the cellulose becomes gas and soot, while the warmth radiates outward to eventually heat the chamber, then the edifice, then disperses into the atmosphere, with not one speck of energy misplaced and the primary law entirely gratified. Now pose a tougher query. What occurred to the information? The exact contour of the letters, the precise words, your signature trace in your personal script? Common intuition declares it is erased, demolished, and irretrievable, for you cannot study the fumes and cinders and reassemble the note's message. Yet this is where physics grows genuinely uneasy, because the answer is not actually a simple destruction, according to the most fundamental stratum of physical law we currently possess, quantum mechanics, and specifically the principle of unitarity. Information is never truly annihilated, ever, in any operation the statutes of physics sanction. The smoke particulates, the thermal radiation, and the accurate dispersal pattern of every molecule that once composed that paper still encode, in principle, what the note stated if you could track every single particle with flawless exactitude, scramble beyond any practical hope of retrieval, but not, per foundational physics, expunged. This is no fringe notion, but one of the most stringently defended principles in contemporary physics, and it is the exact same principle at the nucleus of one of the most celebrated unresolved dilemmas in the field today, the black hole information paradox, which investigates whether data sinking into a void is genuinely annihilated or merely concealed in a configuration we have yet to learn how to interpret. Now apply the paper analogy to your being. Your mind at the instant of your ending is not merely a cluster of atoms, but an almost incomprehensibly precise organization of roughly 86 billion neurons linked by approximately 100 trillion synapses, each holding a portion of the total schema that composes your memory, your character, and your sensation of being you instead of another person. That schema is, in the most literal, tangible sense, information, a configuration of substance and energy precisely analogous to the ink design on the correspondence, just enormously, almost unimaginably more intricate. When you perish, That configuration fails to persist as an operational construct. The exact electrochemical sequence breaks down. Neurons cease firing in coordinated succession, and inside a few minutes a particular arrangement that produced your awareness begins to collapse, and within a window much shorter than most people comprehend, sometimes mere minutes without oxygen. The pattern is no longer restorable by any biological mechanism we recognize. To grasp why information exacts a physical price at all, physics had to endure a century-long snare devised by one of its own progenitors. In 1867, James Clerk Maxwell suggested a conceptual experiment intended to fracture the second law completely. Envision a minute intelligent being stationed at a hatchway between two chambers of vapor, observing individual molecules nearing the opening and permitting rapid warm molecules to pass one way while letting slow cool molecules advance the other, so that given enough time the being sorts a random disordered gas into a heated chamber and a chilled chamber, diminishing entropy seemingly, without cause simply by knowing which molecules were which. For many decades this appeared a genuine loophole until 1961, when Rolf Landauer eventually identified the flaw, demonstrating exactly why the being cannot genuinely cheat the cosmos. Erasing information is not a complementary procedure, as it carries a physical toll, and every instance of data deletion, practically if not foundationally, must be compensated with heat discharged into surroundings as entropy. This is now called Landauer's principle and has received experimental confirmation multiple times, most stringently in a milestone 2012 investigation that measured the minuscule precise heat emitted when a solitary bit of data was wiped in a controlled setting. Landauer's reply was that the hypothetical being was not cost-free. To continue sorting molecules, it must keep rendering judgments, and to create space for each new judgment, it has to delete its recollection of the prior one. An act of erasing that Landauer revealed is not thermodynamically free, but demands energy discharged as heat in a quantity that precisely offsets whatever entropy the being appeared to salvage. So the creature does not fracture the second law, but merely transfers the entropy expense in the vapor into its own memory, and then settles that cost a moment it forgets. Information and entropy, in other terms, are not disconnected concepts that coincidentally echo each other, but are, at the profoundest stratum physics has managed to access, the identical currency. Death, beneath this lens, is the most expansive and comprehensive act of information clearance a physical structure can undergo, not the demolition of energy, which is impossible, but the irreversible scattering of an extraordinarily improbable pattern into the vastly more plausible disarray of the surrounding cosmos. Your body's warmth discharge as you expire and as you decay or are incinerated is not merely a thermodynamic byproduct. In the most profound sense accessible current physics, it is the signature of information being transformed into entropy, the design of you being traded for heat exactly as Landauer's arithmetic demands. This single mechanism of pattern collapsing into entropy is not exclusive to human ending, but is, according to some of the most serious physics being conducted today, perhaps the identical mechanism supervising the fate of data plunging into a gravitational abyss, and even, on the grandest scale conceivable, the destiny of the entire universe. The resemblance is closer than it might initially sound. When Stephen Hawking demonstrated in 1974 that black holes gradually dissipate across time, radiating particles now termed Hawking radiation, he originally deduced that this emission was wholly random, meaning any information regarding what had initially fallen into the void, be it a stellar body, a spacecraft, or a memo carrying your name, would be permanently and hopelessly forfeited when the void finally evaporated. For many years, this information loss paradox positioned Hawking in direct opposition to the unitarity principle at the base of quantum mechanics, which demands information cannot simply dissolve. The dispute grew sufficiently weighty that in 1997 scientist Leonard Susskind undertook a formal scientific wager against Hawking and his colleague Kip Thorne over precisely this query, and the resolution, still vigorously contested today and linked to a concept labeled a holographic principle, wherein the data about everything inside a void may be encoded on its outer frontier, remains one of the most energetic frontiers in theoretical physics. Your cessation and a void's evaporation are mathematically posing the identical unresolved inquiry. When a pattern slips from visibility, has the information truly been eliminated, or has it merely relocated somewhere we do not yet know how to inspect? Zoom outward as far as physics permits, and the second law of thermodynamics declares that in any sealed system entropy, or disorder, never diminishes over duration but only augments or at most remains static. And when applied to the total universe, this yields one of the most solemn projections in cosmology, the heat death of the cosmos, a distant future epic trillions of years onward in which every star is exhausted, every void is vaporized, and energy is distributed so uniformly across. Expanse that no further productive work, no chemistry, no biology, and no cognition is physically feasible, representing maximum entropy and flawless permanent disarray. Under this framework, every deed of order in the cosmos, every star that coalesced, every globe that cooled into something adept at chemistry, and every organism that arranged itself into something capable of thought, is a fleeting localized defiance against entropy, funded by borrowing order from somewhere else and eventually refunding it with interest as heat. And you specifically are one especially intricate illustration of this dynamic. For a stretch of decades, you existed as a wildly improbable island of order within a cosmos that is, on balance, unrelentingly advancing toward chaos. And your death is not an anomaly to this operation, but is the operation unfolding on the magnitude of a solitary human lifetime rather than a galaxy. Yet here lies a nuance that most interpretations of entropy omit, and it is a nuance this entire presentation has been constructing toward. Physicists are deeply polarized over whether maximal disorder genuinely signifies information erased eternally, or whether at the most profound quantum stratum the data is still present merely stretched so thinly and scrambled across so many particles that no observer inside the cosmos could ever feasibly reassemble it. The gap between these two stances is not a technical subtlety, but one of the most hotly debated open questions in theoretical physics, and it pertains exactly as much to a fading star as it does to a fading human. So here resides a discernment this presentation has been assembling incrementally. You're not going to be annihilated when you perish, because absolute physical obliteration is not an operation the cosmos authorizes, as the primary law forbids it directly, and what actually occurs is stranger and in its own manner more exacting. The improbable, ordered, energy-costly arrangement that was competent in reading and grasping this line will scatter into the enormously more plausible disarray of its environment, exactly as Landauer's principle anticipates, and exactly as the second law commands. While your vitality does not evaporate but redistributes itself, obeying preservation, statutes that have never faltered once in the history of physics. Your information, the precise configuration that rendered you instead of any other potential arrangement of identical atoms, does not persist as a working construct, but whether endures in some deeper unitarily protected, physically inscribed format dispersed across the universe is a query that contemporary physics has not definitively resolved. Not because investigators have not attempted, but because the arithmetic of information at the profoundest stratum of reality is still genuinely unsettled. The same unsettled arithmetic currently being contested in the context of black holes a century after Einstein and decades after Hawking first surfaced the paradox. Death, in alternative phrasing, is not the cosmos answering the question of what becomes of you, but the cosmos presenting you the uncompleted form of one of the hardest open dilemmas in modern physics. If this is the initial instance you have encountered mortality, depicted this accurately, not through doctrine or emotion, but through the genuine unsettled mathematics of physics, let your reaction reflect whether that renders it more alarming or somewhat less. There is something authentically peculiar about residing with this knowledge, since most of what we receive about death supplies a tidy response one way or another. Either everything persists or everything simply halts. Yet physics declines to grant you either of those neat conclusions, informing you with absolute certainty that your energy cannot be annihilated, and with equivalent confidence that the specific pattern constituting you will not outlast as a coherent construct. And then at the exact juncture where you most yearn for a concluding answer about whether any fragment of you perseveres in some deeper encoded sense, physics falls silent, not from indifference, but because it sincerely does not yet possess the knowledge. That silence is not a shortcoming of physics, but perhaps the most candid thing physics has ever conveyed to you. So you're left not with an answer because physics lacks one still, but with three potentialities, each regarded seriously by active researchers today, and none of them demonstrably eliminated. The first potentiality is pure randomness. Your pattern disintegrates into entropy entirely and permanently, with nothing about the specific configuration that was you enduring in any meaningful recoverable manner, as the information grows so thoroughly mowed across the universe's remaining span that even in theory no mechanism could ever restore it. And under this view, you are sincerely and conclusively gone, not in breach of physics, but as physics' innate entropic endpoint. The second potentiality involves the multiplicity of realities. If certain readings of quantum mechanics hold validity, the many worlds hypothesis among them, then every conceivable particle configuration, including every conceivable arrangement that could ever generate something functionally indistinguishable from you, exists somewhere throughout the almost boundless branching of quantum results. And under this view, you in some guise and some branch never genuinely cease. The third potentiality involves an undiscovered statute. Physics has been mistaken about final responses previously. For 2 centuries ago, energy and mass were held to be separate, indestructible entities, until Einstein revealed they were transmutable, and it is completely plausible that our current comprehension of information, entropy, and consciousness is absent something equally foundational, some deeper law tethering information to tangible reality in a manner we simply have not identified. Yet, physics will not tell you which of these 3 is accurate, for nobody currently alive can, but will declare with absolute confidence that your vitality, every final measure of it, is traveling somewhere, obeying regulations that have never once been breached in a cosmos that has never, not a single time, truly annihilated anything. If this has shifted how you perceive the physics of your own presence, the most valuable action you can perform instantly is to signal approval, as it is the sole indicator that tells a platform to present this category of contemplation to more people who require it. You commence watching a blaze expire, sure that something had terminated, and physics has just consumed the last segment, proving you were only partially correct.